Hello everyone and welcome to my YouTube channel. While building any software or application, we have a common problems like that runs perfectly on my local machine but fails to work properly on someone else's machine or when deployed to the production. The same issue when I was facing when I was developing an application for mock platform, and it was working fine in my machine but it fails in production. So how to solve this problem? So this problem can be solved by Docker. It solves a problem that it works on my machine's issue. So let's see what actually a Docker is. Let's move ahead to the Docker website. So we can see here this is a Docker website, and in this, what is Docker? It accelerates how you build, share and run applications. This is. Now you can see here Docker helps developer build, share, run and verify applications anywhere without tedious environment configuration or management. So through Docker we can build, we can share, we can run, we can verify. Okay. So we can say that from here Docker is not a programming language, or not it is a framework for building software, right? So Docker helps us to build, share, run and verify our applications anywhere. Okay. Before understanding container, let us understand virtualization, because the techniques which are broadly involved while implementing Docker is nothing but virtualization. So firstly, let's understand what actually virtualization is. Virtualization. You all have used Ubuntu, Red Hat in all your local machine, right? How this is possible when you have one operating system already which you buy from which you buy your laptop or your computer from the market. So we use Ubuntu or Red Hat or any other operating system over another operating system by the help of what? Virtualization techniques. So let me show you when I yes, let's see, when we search, I have VirtualBox, right? VirtualBox created a virtualization on which we had nothing but Ubuntu software which is installed here, right? Ubuntu OS. Now actually what happened, you can do by just dual booting or you can do by technique called virtualization. So we can say virtual machines are an abstract of physical hardware turning our one server into many servers, right? This is the proper, you can see here written like physical hardware which turns one servers to many servers, right? So virtualization allows us to create multiple environments of operating system on a single physical machine. So basically what happens when we look abstract view of our computer system, like you must have read in operating system subjects, right? So you have a hardware, right? What happened on the top of hardware, we have an operating system, and on top of operating system we have called an hypervisor. Hypervisor means like virtual machines, right? Consider yourself like VMware, VirtualBox. These are the applications, right? So these are top on the operating system. So what will happen? Each virtual machine have a full copy of your operating systems and applications. So the problem is like VMware, like you can say virtual machines, it boots slow, right? It's slow down the machines because it have a full copy of operating system, that's why. Okay. So what happened? So Docker come into the picture to solve that problem which we had discussed about. It runs on my machine and it doesn't run on someone else's machine. So to solve that problem, we have a Docker. So actually what do we have Docker? Like first of all, we will discuss about the container. What is Docker container? Docker uses container. A container is a standard unit of software that packages up code and all its dependencies so the applications run quickly and reliably from one computing environment to another computing environment. It means we can say that it has everything to run an application like code, libraries, dependency, etc. Right? Consider we are working on a machine learning project that solves some task and we are working with our team. So all the person who are working in team have a different machines. So to develop this machine learning project, we need to install a lot of libraries and dependency and then start the development. Let's say other people are using any other machine, so to develop this machine learning project, so he or she needs to install the libraries, and if the libraries version have some difference or misses something, then the application will get break. So if anyhow this problem gets solved after developing the project, then it will be sent to the tester. If tester machine doesn't have some libraries, then it will begin, right? It runs on my machine perfectly but fails to work properly on someone else's machine, like the fighting will be started. So this issue can be solved by the help of containers. A container will help you to package up code and all its dependencies so the application runs quickly and reliably, so from one computing environment to another. So making this container, we can easily share and shift to any environment. Like say if I made images of a container, like I made a container, I can share to you, you can just pull it from the Docker and you can use it. The same environment in which I have developed, the same environment you will get that. Okay. So we were working on different machines, but if we are using same container, then we are using the same environment, right? So this will help multiple container running on the top of the hardware. So let's say this is your infrastructure, means we can say this is an hardware. On hardware we have an having nothing but your operating system. An operating system we have a Docker, and on top of Docker we have a container, right, which is containerized application. This is application A, application B, application C, application D, application E, application L. Let's say this application contains Python. This application contains something called Redis, this is nothing but Cassandra, right? So these three different containers are running different things, right? Benefit of running this is like multiple containers can run on the same machine and share the OS kernel, operating system kernel, with other containers. And remember that if they are sharing the same OS kernel but they are in an isolated process, like this, nothing will go out from app A and nothing will come out from app B. Means app A can't share with app B will can't share with app A, like they are in isolated form. Okay, so you can look at these are the containers and virtual machines together. Okay, now let us discuss what is Docker image. Okay, a Docker image is nothing but a template, right, that defines your container. You can think it of as a class and object, right? The images contains the code that will run for any libraries and dependencies your code needs, right? So there are two important principles of the images. Images are immutable. Immutable means once an image is created, it can't be modified. You can only make a new image or add changes on top of it. Means a container having layers of images, right? So image is nothing but the blueprint and container are the exact instances, right? Let's say discuss like for building a house, we make a blueprint, and from blueprint we can make multiple houses on the same, right? So containers images are composed of layers, like this is your container and we have a layers of images, right? And each layer represents a set of file system changes that add, remove or modify files. So in short we can say we use image to create containers and inside them we are running software environments, right? And when you see this is nothing but your comparing your containers and virtual machines. So problem with the virtual machine is nothing but, okay, the problem is like virtual machines are an exact abstraction of your physical hardware, right, which turns your one server into many server. So the hypervisor will allow you multiple VMs to run on a single machine, and main problem is like each virtual machine like this virtual machine, right, this single one virtual machine like includes a full copy of your operating system, the application, necessary binaries and libraries. So it will take up you tons of, you can say 10 of GBs. So VM also boot slow as we discussed, right? But this according to the container, you can see it have packages, codes and dependencies together, and multiple containers run on the same machine and share the OS kernel, right, with other containers which are running in the isolated process. Nothing will go out, nothing will come in, right, in user space. So container take less space than virtual machines, right? So actually what happened, containers images are in MBs and virtual machines like are in taking up GBs, right, and can handle more application and require fewer VMs and operating system. That's why Docker container is lightweight, but virtual machine is nothing but your heavy, that's slow down the operating systems and all. So this is all about your Docker for machine learning, and you can use Docker. And thanks for watching this video. Bye bye everyone.